Alright, we've seen laser cut parts. Now let's jump into creating a 3D printable part. I'm going to create this in a new part studio, though technically we could do it in the same part studio we had here. Let's call this the chassis, and let's call this one a wheel. Alright, instead of on the top plane for this one, I'm going to create this one on the right plane. And since this is a wheel, it makes sense to make it a circle. And this one is going to be a little more freeform, a little less values from the variable studio that we already have defined. So we'll call this the wheel rim. And I can now extrude this. Extrude this part. And let's make this a certain thickness. Sometimes it is nice to still have variables even if they're not defined in the variable studio. Maybe I'll need this dimension a few times still. So I'm going to type the pound sign and call this the wheel thickness. Turns out I've already got that defined elsewhere. So let's call this the demo wheel. The demo wheel thickness. And I can click create new variable. And let's say that this thing is 0.8 centimeters thick, which I think is what I had before too. You can see here I can create links, angles, just numbers or any. We'll click OK. And let's call this the wheel rim. You'll notice that it created the variable right here in place instead of in the variable studio. So this is only shows up here. It does not show up in the other variable studio. Let's do something similar here. I'm going to go actually and edit the sketch itself. I never actually dimensioned it. Let's dimension it to 7 centimeters, which is what the Palalu wheels are that I'm using on my demo robot. Okay, so 7 centimeters. But instead of it being a full thick wheel like this that I'm cut out, let's just do the rim. So I'm going to re-edit this sketch, do another sketch, do another circle, and let's see, how thick do I want this to be? Let's leave that as it is for now, and let me show you a few extra little features here that are useful. Let's see, where do I create variables? Do I have to be outside of a sketch for that? Here we go. So let's click variable, and I'm going to do a measured variable. And let's call this the demo wheel diameter. And let's just click on here. And I think, let's see, what am I going to get as the value? Not generated properly. Let's see, it's a length. Not the edge, no. So is it a distance? Use an axis. This may be a mistake. Measure the distance between the vertex and the edge. It's not complaining anymore, but I can't tell what that actual value is. 3.59. I think I am not going to just try to fix this off the cuff here. I was just trying to show that you can create variables based on measurements. So for example, let me just show you one that I know should work. I can create a variable, let's call it a measured variable, let's call it the test, and the entries to measure between, for example, I could select this edge and get the minimum distance, and it says it's 8 centimeters, which makes sense because that's what we made this length over here. Let's not slow down too much by me trying to figure that out here on the fly though. Okay, so back into our wheel sketch, back into a normal. I'm going to create another circle here and just manually say that this thing is 7 centimeters minus How thick do I want the rim to be? Let's just try 1 centimeter to begin with. That seems pretty reasonable. 1 centimeter thick edge rim there. And since I have both of those, you can see it essentially did a cutout for me. It just extruded the area between the two circles. Okay, but I'm going to have to eventually have a center hub here, and I need something to attach that to. So I'm going to take my right plane, create a sketch, click normal. Let's call these the cross spokes. And I'm going to be sort of just lazy here and do a center point rectangle and not care too much about the dimensions themselves. Oh, let's see, the center spoke, let's see, 1.25 centimeters seems pretty reasonable. And now that's fully dimensioned. Probably would be better to create a variable for those so that if I change one, it changes both, because now I might have to change them both manually. We can do an extrude, and Onshape is smart enough to figure out the overlapping regions for that. And I should make this the same demo thickness. Alright, so now I have a wheel here that I can put a center hub on. So let's do that. I'll click on the top plane again, create another sketch, center circle, and let's call that 1.5 centimeters. That looks a little on the small side. I'll leave that for now though. Let's do an extrude, and let's say that that's twice as thick, so I can take the demo thickness times 2. And those are dimensions we'll probably want to edit as we go forward. Now I need my hole for the shaft of the motor. So here for this I'm going to click on this face, create a sketch. And things get a little bit tricky here when I think about the motor shaft, because it's not just a pure circle. If it was a pure circle, as the shaft spun, it would eventually get loose from the wheel hub, and it would spin free, and the motor and the wheel wouldn't rotate. So if I look at a gear motor from Palalu, you'll notice that the shaft has a flat top to it here. Is there a better look? That's probably a good enough look. They basically shaved down one of the sides of the shaft. And if you look at the dimension diagram for it, it'll actually tell you exactly how much it got shaved down by. So the dimension of the shaft itself is 3 millimeters. So I can come over here and make this circle 3 millimeters. Or I could say motor shaft, and I've already got that value. And now I have a few different ways to handle the next part. I'm going to do this by just drawing a straight line that connects to both parts of the inner circle here. And now what's left is to position this. You can see it's blue because even though it knows that this point is connected to the circle, this point is connected to the circle, and that it's a horizontal line, it doesn't know exactly how far away from the origin it should be. And so for that, I have another distance here, which is the, oh, sorry, not motor bracket, motor shaft. The diameter from the flat side. And that's going to say it can't be resolved because I took that 2.5 from here, this 2.5 value, which is the shaved down part of the shaft. And so I need to actually do some arithmetic to come up with the correct value here instead. So if from here to here is 3 millimeters, and from where the line should end up, let's say it's here, to here is 2.5, we can compute what this distance here is essentially. So that distance is the, sorry, not 3 millimeters. Yeah, the full distance is 3 millimeters. So this distance here is half of that, 1.5 millimeters. And the distance from here to here is 2.5 millimeters minus the 1.5 millimeters from the bottom part. So we should be able to say motor shaft diameter flat minus motor shaft diameter divided by 2. And so that gets us into the correct position here for the part that we'll cut off. Speaking of which, if I were to complete that sketch and then try to do a cut, so let's call this a remove and say through all, it's going to be a little bit confused. And in fact, it just won't let us. So if I click the check on it, you can see it did not properly generate the part. And that's because even though the sketch is fine, it doesn't know how to turn this line and circle into a single part to extrude in one dimension, along one dimension, along one axis. So what I need to do is essentially get rid of this top part of the circle, which I can do with the trim tool. So now that's gone, and my hole should now extrude. Maybe part of the problem was I didn't actually click on the correct face or merge scope. Come on, merge scope. There we go. So now it knows to extrude that shaft all the way through the entire part 1. And so let's rename this part 1 the wheel. And we can rename this the hub, and rename this the shaft. Okay, so now we have something that we can put onto the motor itself. The problem is, unless it's perfectly friction tight on there, it's likely to come off, and it's likely to have a little bit of a wobble to it because we're not going to get it perfectly on there. So one thing that I like to do is to use what are called set pins. So I'm going to bring back in the top plane, create a sketch on the top plane, and we will create a construction point parallel with the origin and dimensioned from this line here. And let's see, do I have an equation for the thickness of the hub? I think so. I think it was the same as the demo wheel thickness. It would probably be worth creating some more descriptive variables instead of just sort of ad hoc remembering that the hub was the same thickness as the wheel itself. But here I've put the construction point at the center of this width here, and we know it's centered vertically because I have it centered on the origin. Now I can do a hole, and let's just say that we're going to do an M2 set screw. So I'll do an M2 hole. And this is the set screw hole. And I can do an extrude. And this time, I'm going to do remove. Instead of doing a remove through all, which would do it, I think, in both directions, actually, it does just do it one direction. So I'll just flip the direction there. So I'll do an extrude through all in one direction. That's right. If I wanted to, I could make it symmetric and go in both directions. But let's turn off being symmetric. So that's the set screw hole. Okay, so that's the hole of the threaded part of a set screw that I want to go all the way down. Let's say set screw, to show you what one of these looks like. I'm picturing something like this one here that has a head at the top of it. The one that I have that I'm using has round heads. So essentially what I want to do is create a rounder part here for the head to sink down into the hub as well. And then I can just use a screwdriver to screw it down in. So what I'm going to do is create what's a new plane called a new sketch plane, because I want to sketch here at the top of this surface instead of all the way down below. So where is sketch plane? Here's a plane. I'm going to make it an offset from the top plane and bring it down. What do I have the hub radius at? That's at 0.72. That doesn't look quite right. Let's look at the hub. The hub has a diameter of 1.5, and this would actually be a good point. Let's call this the hub demo hub diameter. Create a new variable. So now I can use that when creating my plane here. Divided by 2. So now that sketch plane I created is perfectly at the top of the hub. So I'm going to hide the top plane and click on the sketch plane I just created, create a new sketch, and do a center point rectangle. Let's see, let's do a construction and use. I think I should be able to grab that. And now I can do a center point circle. Oh, I still was in construction mode. Create a circle, and let's say the head of my set screw. It's an M2 set screw, and let's say that the head is just 20% larger. That seems a little small. Let's do 40% larger. Let's call that the set screw head, and do an extrude. We'll do a remove, and let's go 0.2 cm. How does that seem? Normally I would just measure these, but I don't have these measurements in my variable studio, so we'll just say that's reasonable. So now you can see the head will sink down, but the set screw itself will go all the way down into the center shaft. Alright, it's pretty common to have multiple set screws. So this might be the set screw that goes into the flat part. But to make it adjustable so that I can easily get rid of wobble, it's handy to have multiple set screws. So here I'll show you how to create 3 separate set screws. And let's hide that plane. So instead of redesigning additional holes from scratch, instead I'm going to use what's called a circular pattern. And this is going to be a circular pattern, not a part pattern, but a feature pattern. And I am going to feature around, feature the hole that I have there and the set screw hole as well, and around this axis. And let's just do 3 of them. Reapply features. And now I have the space for the head, space for the set screw, and all 3 come into this center shaft. So I can have set screws coming in from 3 different directions. Alright, just like I like to have smooth edges on my laser cut parts, I also like to have smoothed out corners on my 3D printed parts. So for that reason I'm going to add some fillets here for strength. They also just make the parts look nicer. And that actually looks pretty reasonable. Now this one is for strength. I'm going to add a separate fillet around this just to make sure that that hub is nice and strong and it's not likely to break. The rest I do want to be flat. I've also found that with 3D printed parts, this 3D printed hard plastic has really low friction, and so it doesn't work on most surfaces. Even carpet, it has a tendency to slip. So I like to put a rubber band around the edge of my 3D printed wheels. And the rubber bands will stick better if we give them a little indentation to go into. So for that, I'm going to sketch on the front plane. And what we're going to do is just create a little cutout here that goes all the way around the edge of the wheel. So probably the best place to start would be to do a construction of a use and take this top line here. So then I can then do a construction point in the center, and now I can have a circle that I can dimension off of that. That's a construction circle, which won't do the sweep feature that I want it to do, so I'll undo that. And I'll do a new circle, line it up, and now this circle will do what I want it to. Let's see, 1.3, that seems fairly nice. Let's make it 1.4 to make the hole a little bit shallower. And if that's 1.4, the distance here should be like 1.4 divided by 2, which means there's no cutout. And then let's take out a little bit of a chunk. 0.1 centimeters. That's a little more than I think I'd want to do for a... Let's try half that. A little more than I'd want to do for just like a slot for a rubber band. Okay, so now we have a sketch, and I can now revolve that all the way around the wheel. So if I can remember how to do that, I think it's a revolve. And we're going to do a remove. Faces and sketch regions to revolve. So we're going to revolve this thing around... See if I click, was that the correct axis? No. That axis. And we're going to remove from the wheel, and it automatically picked that up because it's the only part. So now you can see I've got a little groove here that means that when I put a rubber band on there, it doesn't slide off all the time. Okay, one last part, one last feature to add to this wheel. If I were to put a set screw down this hole, it's likely to get loose over time. One thing to help something from getting loose on a set screw is to also add a nut. So what I'd like to do is just slot a nut in through the face here, and then have the screw come down from the top, screw through the nut, and then screw down into the motor shaft. So I'm going to sketch on this front plane here, and from the side a nut looks like a square. And these are dimensions that actually do work for the nut that I'm using. I just happen to remember offhand, but normally I would put these into the variable studio. I'm trying to not make this video too long and boring here. Okay, so those are not fully dimensioned because I don't have them a specific distance away from the middle shaft. Let's just move them 0.35. And I don't think that will interfere with the head slot. So now I can cut this in with an extrude, remove, and let's see, this should go the thickness, demo thickness. So now you can see I can put a nut, a square nut, hexagonal nut into here and screw down into it. One problem you might see is I don't have that same feature for my other set screws. But one nice thing is if I move these up, let's call this the nut cutout, if I move both of these up above the circular pattern, I can then edit the circular pattern and add that as another feature to pattern. This is starting to look a little like Swiss cheese, probably not going to print very well. So what I would probably want to do is increase the hub diameter. So let's call that 1.75. Give it a little more space everywhere. Since I didn't dimension all my other parts off of that, you can see they still stayed fairly compact. So as you start to play around with creating new parts, you'll find, okay, well, I know that I want this nut cut out to move whenever I make this hub larger. So instead of dimensioning it off this bottom part, maybe really what I should do is dimension off the outer edge, which does move in fact. And now if I were to go back and make this even larger, these parts all stretched out a little bit more as well. It does now not like some of the fillets that I've got constructed, because this line here is now broken, so it doesn't know what to do with it. So I can actually just recreate that from scratch, and it'll learn to live with it under certain circumstances. Apparently not this one. Not totally sure what it doesn't like there, but one thing I can do is just reduce the size. Usually helps. It seems happy enough, and that's probably strong enough. It also got rid of the fillets on some of these parts, which I can just get rid of. And if I wanted to, I could add back in on both sides. The final part here is to right-click, export, and the 3D printers at the makerspace will take both the 3MF format and the STL format. The STL format's been around longer, has a couple of annoying things about it, like it doesn't actually embed the units here, so you'll have to remember that you used centimeters. 3MF does embed the units, but almost every printer that exists is going to work with STL, so it's a little bit safer to export into that format instead. Alright, happy 3D printing and laser cutting.